Welcome to GC Connect. In the previous class, we are discussing about the different types of cement, and if you want to test that cement, you have to use that specific code only. In that specific code, they have mentioned what proportion of the cement you have to take, what proportion of lime you have to take, and how you have to test all the different types of cement. And it is very clear that uh, the type of test is depends on the type of the cement. Of course, that is why they have established the different codes, and you have to strictly follow that codes for testing the cement. And sometimes they will ask how we are going to make the cube, what kind of proportions we have to use, and that kind of things they will ask. For that, this is a simple procedure is there, uh, and this procedure has been taken from the IS code itself. So if you want to make it the cube test, so then what proportion of the cement you have to mix it, what proportion of water you have to mix it, that all things should be discussed properly if they have asked in the examination. So take uh, 5 grams of standard sand, so 185 grams of cement. Of course, that is a 1:3 ratio of the cement and sand. Mix them for 1 minute, then add. So you have to mix it well initially, then add the water, that is with the quantity of p by 4. Total quantity is there divided by 4, then plus or minus with a plus of 3% of that total quantity you have to add it. Then mix three ingredients thoroughly until the mixture is uniform color. So this is very important. The third step is very important. So even if you add the 1:3 quantity, if you don't mix it well, so whatever the pozzolanic activity is there, it won't come. So then time of mixing should not be less than 3 minutes, and it should not be more than 4 minutes. So this is a standard time. So normally the mixing process is there with constant speed. Constant speed means like what? With a constant mixing process. It should not be like what, too much of a pressure you have to apply and you have to mix it. So with a constant mixing, so that mixing process is there. Again, you have to follow that IS code only if you want to see how to mix. And normally in manual mixing, how much it is there, and machine mixing, what how much rpm you have to fix it with the speed of the motor. So the time of mixing should not be less than minute, and it should not be more than 4 minutes. Then the mortar is filled into the cube mold of 7.06 centimeter. Of course, that much height is there. The cube standard cube dimensions I have already mentioned in the previous class. So then compact the mortar. First you have to compact the mortar with the compacting unit. Then keep the compacted cube in the mold at a temperature of 27 degrees centigrade plus or minus 2 degrees centigrade, and at least for 90% relative humidity. That I already discussed when we are conducting the standard consistency test. So then humidity for 24 hours. After 24 hours, the cubes are removed and immersed in a clean fresh water until taken for testing. Normally, this is where the last one is very important, because normally we have to use the clean fresh water only. You are not supposed to dip that water into the mud water. Normally, what will happen is that normally small pores will be there, uh, even after mm, curing, that whatever the small mud particles will be there, that it will go inside the concrete, and it may lose its strength during the strength test. So this is a typical process of um, uh, preparation of the uh, cubes for the cube test. And the next is what kind of test we are going to conduct it on concrete. So in the previous classes we have covered with different types of test on the cement. Now what type of test we are going to conduct it on concrete. So now the concrete is an artificial stone which is widely used in the construction field. So these are the mainly 5 components of the concrete. First one is air, second one is cement, third one is coarse aggregate, fine aggregate, and water. So normally we will discuss only 3, that is cement, coarse aggregate, fine aggregate, but we have to consider the air as well as the water, because curing time is very important, air curing as well as the water curing. So whenever whenever we are giving the importance for all 3, we have to give the importance for all 5 parts of this concrete. Sometimes we have to do the air curing, where the moisture level will be more, there we'll use it. If the moisture is very less, then we'll go for the water curing for 7 days, 14 days, 28 days, like that. So then the classification of the concrete is, depending upon the state, the concrete is classified into 2 types. The first one is fresh concrete, second one is hardened concrete. So fresh concrete, it can be placed into the forms to produce large variety of structural elements. So the hardened concrete, it is a strong compressive strength but lacks of tensile strength. So this is what the main difference of the fresh and the hardened concrete. So these are the different properties of concrete. So um, it play a very important role in deciding the quality and quantity of the concrete. So first one is fresh concrete, that is a workability. Second one is segregation. Third one is bleeding. For the hardened concrete, that is, the first one is strength, second one is impermeability, the third one is durability, and fourth one is dimensional variations. So we'll discuss in detail for all these tests. Maybe in your basic material testing lab and concrete lab, we have covered all these tests, but still they have mentioned in the syllabus that what are the different tests are which are going to conduct it on concrete, that we have to see. So the first one is fresh concrete. So now in that, the workability. So the workability of a concrete means the ability to do the work with concrete. Normal, it is like work done. Work done means energy required per unit uh, mm, volume of the concrete. So now different tests for workability, that is for workability, slump test, compaction factor test, that is web test, we will do it. Maybe you did with a slump test, not the compaction factor test. Maybe web test also you have not done it, but a slump test is very important. So then this slump test, how we are going to conduct it? It is used to determine the workability of the concrete, of course. So normally what they will do is that in the slump test, the vertical settlement of the fresh concrete can be tested. So normally one mold will be there. Mold is of a cylindrical shape. It is not that much cone type. That edge of that cone, it will be uh, divided, or it will be uh, cutted into 2 portions, and the bottom portion you have to select it. So then what you have to do is that we have to pour all the concrete to that mold which you are seeing in the left diagram. Then slowly, when mm, fill it, compact it, and slowly release the at both sides, it should be open, and slowly we have to release it. Once you release that uh, once you release that mold, then it has to make the shape of the cone, then it should not be disturbed or it should not going to collapse. So it is measured as the difference between the height of the mold and height of the point of the subsidized concrete. Normally, um, so how much height of this um, uh, slump it is making, that we are measuring it here. Normally when you release it, it has to, whatever the cone portion is there, that has to remain for at least 2 minutes. So then the test is good. So it is not suitable for very wet or very dry concrete mixes. Of course we will take, if it is wet we will not use, but even it should, if it is dry also, normally it is going to collapse. At least if you release the concrete from the mold, it has to hold for minimum 2 minutes. So then if the aggregate is more than 40 mm, your slump test will not work, because normally the density of the or the size of the aggregate is going to increase, and it will not fit into the mold. If for 4 or 5 aggregates if you take it, normally it is going to fill, and the total volume of the aggregates is going to increase. If the total volume of the aggregate is going to increase, normally we will lose the slump. So then suitable, when it is suitable for concrete of medium and high workability, the slump value um, of 25 to 125 mm is required. So then this much height at least it has to retain during the slump test. So then maybe I'll take you to the lab and we'll conduct 1 or 2 tests on this. Maybe you have conducted this test on the first year also. So then IS code, it has been done, the slump test is conducted as for the IS code, that is 73201974. We have to follow this code for finding the workability. So maybe in the next class we will start with uh, the again start with different types of test on concrete except this workability. Thank you.